All right, so just so you understand, like in cap plate situations, we do take for example, the column could be a steel pipe, it could be a W beam, it could be a square tube, rectangular tube, whatever the case may be. But to keep things simple, when they cap it, they're just going to take a plate, cut it out to the exact same cross section, just lay it on top. And they won't bother showing it to you in a detailed view. So what they'll do is, here's a side view of your column. Let's say the column by chance is a square tube. What visual line type should I have right here, you think? Hidden lines to show the inside walls, right? Now, what if I didn't do hidden lines, just curiosity? What if I drew, that was a horrible line, try that again. What if I drew a line like this, and I said this is a column? What shape do you know that it is now? An I-beam or W-beam, most commonly. Because of the fact you see the edges, right? So that's the difference. Now, on a set of plans, someone may not even show you anything. They'll just tell you what the part is. Anyway, as far as the cap goes, caps can be roughly about 3/8 is a pretty common size for cap. However, they can go to 1/2 inch and that kind of thing. So here is the process. They'll just show you this detail, and they're just going to do this. They're going to throw the weld symbol on it. It's going to be an all the way around kind of thing. And what kind of weld would you probably have to do to get this cap to fit right on here? Yeah, groove weld will probably work. And technically, they could get by with actually doing a V-groove this way and saying all around, or they may actually show it this way. From the top, what would that look like? It just basically looks like this. But they're not going to show you the top view because there's just no point in showing this to you. They're just going to say, here's the column. They may call this out. And typically, section views do not actually have the actual item sizes called out. Like, they're going to show you the column size on a plan view, but they may say that this is a 3" or 3/8 cap. Is there a reason they may not give you the dimensions right here in this view of the cap? Yeah, and I say dimensions, I mean the dimensions of the cap. Why would they not bother telling you what the dimensions of the cap are, other than its thickness? Well, I'm talking about not the actual dimension or weld size. I just mean the actual plate size. So, for example, let's say this was technically a 5x5 3/8 plate. Why are they not going to bother telling you the 5x5? Yeah, it's going to be the same size. I see what you're saying. It's the same size as that because it's the V-groove there. And that's just the nature of structural fabrication. They'll just say 3" plate. Or 3/8 shear clip, because most of that stuff is very standardized. They're just going to take the dimensions of the tube that's called out and say, we're cutting a bunch of plates like this. So in the actual, if you're given this kind of drawing, none of this information will be provided except maybe, they'll say cap plate, if at all, and they'll have that noted somewhere else. They may actually say it's 3/8, but it's unlikely that they're actually going to give the dimensions on this section view. The key thing of this view, though, is providing that right there. Just saying, hey, you're all the way around, you're going to do a V-groove, and then, of course, you may set something on top of this. All right, so you can get by with actually only having to do one view to show all this complex connection. That's a good question, actually. Why do we actually put cap plates on when we're going to turn around and set something on top of it? So let's say, here we go, we'll zoom in a little bit, and we've got this column coming up, and it's a steel tube. So there's your hidden line for your wall thickness. And why don't we just throw the W-beam on top of it and go to town? All right. The reason we do the cap plates is typically a stress and basically to transfer stress more effectively, especially if we're going to weld. Now, in a lot of cases of cap plates, the cap plate will often be bigger than this, which would call for dimensions, because that allows me to turn around and bolt my beam to my cap plate. Got to have clearance, got to be able to get in there and have my wrench or my electric wrench system to have enough clearance to get in and bolt the thing down, so I got to make my cap plates big. Plus, I also have to meet the basic requirements of steel design, which is typically a 1.5" clearance from the edge of the steel plate to the center of the bolt hole. So we might weld right here for sure, but we're going to bolt the steel beam, which in this case is going to be a W-beam, to the top plate. Now, if we're going to weld, we may not actually build this plate so big. But what we might do is make it big, bolt 1 or 2 points to get it seated, and then come back and actually weld it. So there's a lot of variety there in how they do it. But pretty much they're always going to put a cap plate on things, mainly because it helps to create a solid bond of weld or connection between your beam system and your column. What happens is if you do a column and you don't get, like say you get a good, you don't put a cap plate on and you get a good weld here, but in the field you get a little burn through or something like that. What happens is now this column in this beam system doesn't perform the way it was designed to, and that can affect the calculations a lot. So that, to avoid the problem, they like those nice shop welded caps, which creates a great place for a good weld on top side to get a good bind between the two, a good functional connection. So that's a very good question, is why we put them on even when we're going to connect something on top of it. Convenience and connection, stress is the key thing there. Stress transfer. Other questions?
Yes.
Yeah.
The W beam on top, is it going in the middle, column in the middle of the I beam, or is it the
All right, so is the W beam for this like scenario, does the W beam do this, and here we've got this scenario, or is it like
fill it weld all the way around, so I assume the beam's in the middle?
beams in the middle? Yeah. Or actually the column, the beam is continuing on its span, is the way to think of it. Yeah. Yep. That's a good question. Any others? All right. Now, could a person get by with doing this a different view? Possibly. They could possibly do it like this, where here's the W beam, here's the cap plate, and here's the column there. You could probably do most everything here. I think you get more out of the side view though if you wanted to.